friends! Welcome to Coding Garden with CJ. Welcome to Code Katas, number 17. We've been doing a lot of these. I am extremely late, and I apologize for all of you that have been waiting for me, but we're here, we're live, it's happening. Let's kind of get started. So, if you're not familiar with the show, and before I get started, Flux is on. Make sure I turn this off. There we go. So that's a tool I use to remove the blue light at night, and it's actually pretty late. Okay, but Code Katas. So this is a stream that I've been doing pretty regularly. Happens every Wednesday. I have this GitHub repo, github.com/codinggarden/code-katas. You can see all of the past katas that I've solved, and I have links to the ones that I'm going to solve today. Let's say hello to all the people in the chat. And again, I apologize for being late. Hello, Ramsey. Sorry, I'm keeping you up late. And Ren, oh, you gotta tune in tomorrow. That's okay. Hello, gaming, but not really. And Scott, finally here for a live stream. Welcome. AL, hello. And JT, welcome to the show. Alicia, hello. Alicia mentions I should do a Teaching Teachers to Teach series. My probability and statistics professor sure could use some help. Maybe. I think it's a lot harder, I feel, for college professors. Just because they're teaching at such a high level. I'd use quotations there. I don't know. Vias, hello, welcome. And my username is Ryder, working overnight shifts, tuning into the coding train. Hello, Jan, welcome back. And Alka, hello, and Wally. Hope I didn't miss anyone. Yes, I picked out a few from today, and actually a few of them were user suggestions. So on the GitHub repo, if you go into issues, there's one issue where you can suggest katas for me to solve. And I'm actually doing two suggestions today. One of them is from Mer Chan. This is a long time coming. He suggested this one a while back, and I've actively been avoiding it, but it's one that he created himself, but I'm going to attempt to do it tonight. And then also California recommended this 6Q. They also recommended this 2Q, which seems pretty hard. It's probably something that would take me an hour, maybe 2 hours, if or more, but it's a very hard one. But I'm going to do one that he suggested as well. Cool. So the first one, I'm going to start a little bit easier. So it goes from increasing difficulty from easier to harder. So first we'll start with ones and zeros, which is a 7Q. Then we'll do one line task, square every digit. This is the one that was suggested by California. And actually it was because I've done one very similar in the past, but this one has the one caveat that I think you're limited to a certain number of characters, so 36 or fewer in JavaScript, so you have to actually solve it in one line of code. This is the one suggested by Mer Chan. This is exponential comparison. It's a 6Q. And then lastly, there is a 5Q called double cola. Cool. Yes, and before I get started, a question from Gaming But Not Really. Wanted to rewrite your code solutions in Java. What would be the most effective way to do this so everyone will be able to access the Java solutions? You could definitely just create your own GitHub repo, and I have no problem linking it in the README. That could be even something that we do if other people want to do it in other languages. But yeah, if you create your own GitHub repo and push everything up there, I would have no problem just throwing a link right here in the README and say, hey, go check out the Java solutions over there. And you could even open a pull request here to update the README. Absolutely. Cool. Maro, you have not missed anything. I am just getting started. And hello, Alan. Welcome. Okay, so let's get into it. First one, we're going to start a little bit easier with a 7Q for ones and zeros. Let's give us a little bit more real estate. Cool. So here's the problem. Given an array of ones and zeros, convert the equivalent binary value to an integer. So for example, you're given an array with 0, 0, 0, 1, and you have to turn this into the decimal representation, which is 1. And so essentially you're given an array that represents each binary digit, and you have to give back the decimal representation. So let's give it a try. I like to bring these down locally. So let's create a new file, ones and zeros. Is that how you spell zeros? Is there an E in zeros? There's not an E in zeros. Let's rename this. Cool. And This will be a fun one, and I think before I get into it, I'll kind of talk about binary too, if you're not familiar with how that works. So let's just make these console logs. And we'll get into it. So I like to use a thing called Quokka.js. It actually runs your code inside of VS Code, and any console logs get printed like right inside. So that's pretty cool. And right now, our function is not returning anything. So all of these are returning undefined, and it shows the expected value on the right-hand side. Cool. And Daniel, hello, welcome. First time catching you live. Found you from the coding train. Oh, and Skelly, hello, welcome. Okay, so first let's talk about binary representation. So if we consider this representation like 0, 0, 0, 1. The way binary works is you represent numbers using just 2 digits, 0 and 1, and the idea is that each place in the number represents a various power of 2. So this written out is actually exactly the same thing as, so this would be 0, 1, 2, 3. This would be 2 to the third power times 0 plus 2 to the second power times 0. So this is 2 to the third power times 0. This is 2 to the second power times 0. This is 2 to the first power times 0. So 2 to the first power times 0. And then lastly, we have 2 to the 0th power times 1. So if we do all of this math in decimal, we'll actually get back the number 1, because 0 times anything is 0. So this becomes 0 plus 0 times anything is 0 plus 0. And then 2 to the 0th power is 1. You can prove that 2 to the 0th power is 1. So this would be 1 times 1. So this would be plus 1. And if we add all these up, we get the value 1. So basically, you can take a number that's represented in binary, and each place is that power of 2 times either 0 or 1, and then you add it all together. And it's, I guess, interesting to note, our decimal system actually works in the same way. You may not have seen it broken down this way before, but like, let's take the value 123. This is actually 10 raised to the 0, 1, 2, 10 to the second power times 1, plus 10 to the first power times 2, plus 10 to the 0th power times 3. And if we do this math, we'll actually get back 1, 2, 3. So 10 to the second power is, 10 times 10 is 100, times 1 is 100. 10 to the first power is 10, times 2 is 20. And 10 to the 0th power is 1, times 3 is 3. And if you add all these back together, you get 1, 2, 3. So even our decimal system is basically broken down in this way, and binary is just another way to represent numbers using only 2 digits instead of 10 digits, which is pretty cool. And JT is mentioning show us some hex. I don't know if I'm going to do the math there, but it's a similar idea. Instead of, so binary, you have two characters to represent each place. Decimal, you have 10 characters to represent each place, the numbers 0 through 9. Hexadecimal has hex-a-decimal. So hexadecimal has 16 different characters. So 0 through 9, and then A through F, I believe. And it works the same ways, but in this case, it's just 16 raised to some power times that given place, which is pretty cool. And if you've never seen numbers broken down like this, it's actually pretty enlightening. But basically, that's what we have to do. We're given this array, and we need to sum up each place in the array raised to a given power. So let's figure out how we'll do this. So we are given the array, and we're going to need to iterate over it. And we also we could have some sort of like rolling sum, right? We could calculate each place, add it onto the sum, and at the end return the sum. So we need a place to store the sum, and then we will iterate over the array. And we will take the current value raised to array.length. So the length of this array is 4. And the places are going to go 0, 1, 2, 3. So the place will be raised to array.length -1 minus I. Because I will start off at 0, so array length will be 4, -1 will be 3, so we'll have 0 to 2 to the third power times 0, and then we'll come back around and I will be 1, so then this will be 4 minus 1 is 3, minus 1 is 2, so to the second power. So basically this is going to be our exponent that we're keeping track of. So take the current value raised to, well, it's not the current value. Let's take, sorry. Take 2 raised to that power. And multiply by current value in the array. Cool. Let it be known there are probably a lot of other ways to do this, but this is the way I'm thinking about it right now. Basically, we're going to iterate from the beginning to the end, and each place in the array, we're deciding what the power of 2 will be raised to, and then we're multiplying the current value in the array. And we'll take this and add to sum. Do that for each one, and then return the sum. Cool. And hello, Danny Fritz, welcome. A wonderful joke if you're not, if you haven't like learned binary before. There are 1-0 types of people in the world: those that know binary and those that don't, and those that didn't know it was trinary. Cool. And hello, Tanis, welcome to the stream, and Bob, welcome. Tal is asking about securing the code and CSRF attacks. This stream is about solving coding problems, not exactly about security. Maybe in a future stream we'll talk about that kind of stuff. Okay, let's do it though. So we need a place to store the sum. This will be, it has to be a let because we're going to be modifying it. So I'll start it off at 0. Then we need to iterate over the array. Technically we could use a for each. Let's just use a for loop. And we're going to be iterating over this variable r, and instead of calling this element, let's call this value. So we're iterating over the array, and then we need to do these things. So take 2 raised to the power of array.length -1 minus I. So we'll do, actually, let's see which version of Node. Yeah, so this is using Node version 8, so I believe we can use the exponentiation operator. So that works like this. This is basically new syntactic sugar for math.pow. So we want 2 raised to this power times the current value in the array, and we're going to add that to sum. So we'll say sum plus equals that. So we take 2 raised to, in this case, it's going to be the third power, because we know that all of these are of length 4. So 2 raised to the third power times the current value, and then 2 raised to the second power times that value, and etc. And then now we can just return the sum. And this needs to be R, not array. Okay. And we have not done it. I've made a terrible mistake. Let's figure out what it is. But let me catch up on the check. Yes, and AL is asking about what extension is showing the results and errors. This is called Quokka. It's really cool. Any console logs that you have inside of VS Code will just log out right there. We're doing something horribly wrong. What are we doing? Let's log some things out, and let's actually like store this in a variable. So this will be power of 2? No, not power of 2. Let's just call it that. I don't know if that's the right name, but we'll store that there, and then let's log the power of 2. And let's only run this one. 15, 14, 13, and 12. Definitely doing something wrong. Let's put this in a variable. So this is going to be, this is really the power of 2. We'll call this the power. And 2 raised to that power. You know what it was? Order of operations. This whole thing needed to be in parentheses. That's why it wasn't working. Okay, you know what? I like it with multiple variables though. Let's keep it that way, and then I'll rewrite it with all on one line. But basically what was happening was it was 2 raised to array length. So a power will happen, then it'll subtract 1, and then it'll subtract I. So by storing it in a variable first, now it's actually raised to the correct power. So this should do it. And we want to add on the power of 2, and we get 15. Why? Okay, so Alicia did mention we need the extra set of parentheses. Oh, I'm not using value anymore. Value times power of 2. Whew. I have had a long day, but there's our answer. We're gonna break this down. We're gonna write it like 4 different ways, but we've finally done it. Okay, cool. So we're iterating over the array. We grabbed our power. We raised 2 to that given power. We then multiplied that times the current value in the array, added it onto sum, and we get our result. Okay. Oh, and JT is mentioning most languages don't respect proper order of operations. This was definitely my fault though. Like this whole thing needs to be in a single value that it is raised to the power of. Comment from Anders. Glad I could join one of these streams. I love these coding katas. They're really valuable and showing me how to use different stuff in JavaScript. Awesome. Glad to hear it. Yeah, and I love using, so one thing I'll show is like, we could do this with a for each. We could probably do this with a reduce because we're taking an array and reducing it down to a single value. Okay, so first thing I'll do, let's just rewrite it, but let's try to do it all on one line instead of with multiple variables. So the issue here was this whole thing needed to be wrapped in parentheses. And now we can take that and put that on power. Cool. And then now this whole thing wrapped in parentheses should be multiplied by value. And right now I have 2 const variables. I'm just going to turn this into a regular old function, just so that the one below it overrides. And I can have both of them in the file. Cool. So this works, but we took our broken down code and kind of like wrote it all on one line. Awesome. Let's just see this with the for each, because then it will be a bit easier to see how you take something like a for each and turn it into a reduce. So basically, instead of this for loop here, we want to do a for each on the array. So let's do array.forEach. This is going to give us each value in the array. And now we can take this code that was in the for loop and just throw it in here. One issue is we do need the current index in the array. For each will give that to you. It's the second parameter to the function. So you have the value in the array and then the index. And this will do exactly the same thing, but now we're just iterating over the array. We have each value, we have its index. We're calculating that there. So that's fun. Cool. Lots of new people in the stream. It's great. But Tails is asking, how am I debugging like this? Quokka. And you know what? Any representatives of Quokka, if you're watching, I would love a sponsorship. That'd be awesome. But Quokka.js is really cool. I'm actually just using, they have like a community version, and then there's a paid for version, which has a few more features in it. But it will log things out that you log out in line. It's super interesting. If you log inside of a for each, like here, let's just log sum. You can see every value of sum every time this this function in the for each ran, which is pretty cool. Really great for debugging. Okay. JT is suggesting a one-line recursive function. We can try. I think one last thing I'll do is take this and turn it into a reduce. And we know we can use a reduce here because we're taking this array and reducing it to a single value, a sum, basically. It's a more complex sum than just summing all the values in the array, but it's very similar. So we could take this and watch this. So we're going to change this to be a reduce. A reduce gets the accumulator, so our variable becomes now the first parameter in here. And then a reduce accepts a second parameter, which is where does that accumulator start? And the accumulator here starts at 0, so this will be 0. Now we want to just return this whole thing, but we can't return sum plus equals. We'll return sum plus that value, and that does it. That's sweet, right? But now we could turn this into a one-liner because well, notice there's a single line of code in this function, and we're just immediately returning the value. So let's get even trickier. So instead of curly braces and returning, we can just do that. And that is kind of hard to read, but it still works. We can see down here. So you take the array, you reduce it, you have your sum, which is your accumulator, you have each value in the array, and you have the current index. And so then we're taking the current sum every time and adding on this value here. Cool. And right now, order of operations is in play because technically, I mean, I could wrap this in parentheses, but because it's a multiplication, that will happen first, and then it will be added on to the sum. So that's cool. Danny Fritz is suggesting a MapReduce. So it'll be more iterations, but it'd be cool to see because basically we could take this array, turn it into a new array that is the corresponding value, and then reduce that to be the sum. I like that. Let's do it. So we'll kind of let's take this one. We'll probably turn it into a one-liner. So basically, instead of reducing first, we want to map the array. And this is the value that we want for each value in the array. So let's grab that. And now we can turn this into a map. So we're going to map over the array. And for each value in the array, we want to do this. But we also need the index to get the right exponent. And then after we've mapped it, we now have an array of the corresponding values, and then we reduce that to get the total sum. And this could be a nice little one-liner, like that. Look at that. Cool. It is important to note, though, like if we're talking about number of iterations, a reduce will do this in a single iteration, whereas this takes one iteration and then another. In terms of like code readability, I kind of do like the MapReduce a little bit better than just the plain old reduce, especially if you're trying to do like one-line functions. Can anyone think of a better way to do like raising this exponent? So I think right now I am I'm basically like iterating from the beginning of the array to the end of the array. I guess technically, if I iterated from the end to the beginning, I could actually have a value counting up from 0 while it's going backwards. I don't know. Skelly is mentioning ParseInt is perfect if you don't want to do math. Where exactly might I use that? Oh, and there's a comment from Ilman. Cannot wait for your next course about Vue, Vuex, and ViewRouter. I definitely want to do a Vue course. I've been thinking about it for so long. I moved to New York City for a while, so I was like very busy. But that might be one of the things that I do pretty soon, like a Vue course, because I like Vue.js. Though actually tomorrow I'm speaking at a meetup and I'm actually writing React, which will be fun. But okay, how might we write this recursively? Yeah, so time for the recursive version. I guess basically, let's think about it. So let me just start with a blank function and let's try to kind of do some pseudocode here to see how we might do this recursively. If you've watched this stream in the past, I tend to fail miserably at trying to turn something into a recursive function. So definitely could use some help, but let's see if I can get it. So here's what I'm thinking. We get an array. We want to return the like this value here for like the we could do it for like the last value in the array. No, we could do it for the first value in the array, because then, okay, let me write this out. So we want to return the calculated value for the first value in the array added to the recursive call with the array missing the first value. And then our base case will be, and I guess we will need a base case, like if the array length is 0, return the sum. Something like that, yeah. Gaming but not really is mentioning it's 2 to the I minus 1 technically. Oh, that's a lot easier actually. Because if, well, if we're going in reverse, because if we're starting here, then this is 2 to the 3rd power. So we actually do need a larger number. Cool. Oh yeah, and I think I missed some chats. Maro, hello. Since the live with the coding train, I've learned a lot. Thanks to you. Appreciate it. Okay. Oh, and I think I'm gonna try to do the recursive one, but there is a good suggestion in the chat from Alicia. Reverse the array, then it can be 2 to the I, because if you reverse it, then it's 0, 1, 2, 3. I like that. Yeah, and so Danny is mentioning you pop until the array is empty. So basically, this recursive call here, would we do a pop or an unshift? Because the way I'm thinking about it is you're taking off the first value. Cool. Yeah, and JT's mentioning I'll need a ternary. It's basically like you need the base case for this recursive function. And so if the sum is 0, return 0. Okay, let's try it. Okay, so we basically need to do this calculation. We've already figured that out. So return. So and what we need to see is like, and what JT is suggesting. So if we just if the array length here is 0, then this is going to be we don't have I. It's just going to be -1, because it's always going to be the first value in the array. But if the array length is 0, what is 2 to the -1 power? Half? I guess we probably need to check the array length. So if array.length, then return this plus the recursive call of the array.slice. I think we want to slice it after the first one. So the index at the beginning of the specified portion. Oh, so this is talking about a string, but I think this should work for array. I'll double check it on MDN, but basically this will remove the first value in the array. Let's double check. Array splice. Because if I do an unshift, my thought is that it will return the removed value rather than modify the array, and like return the array itself. Splice. What about slice? Did I search for? What about slice? Array slice. returns a shallow copy of the portion of the array. So if you give it an index, it starts there and gives you the rest of the array. So that should do it. So this is going to basically remove the first value of the array and recall that. And if the array length is that, otherwise 0. And value is not defined because it's just going to be array at 0. Huh? Look at me! Look at me! First try. Okay. Let's, instead of doing this with a ternary, let's just write it out to see what's happening here, because it's a bit to take in. So if array.length is equal to 0, then return 0. Else, we're going to return this. Wait, did I copy and paste it? No, I didn't. Let me copy paste it, and then we'll write it out. Okay. So if array.length, and really that's so I'm using the truthy falsy aspect of JavaScript. So if the length of the array is 0, then it's false. So if array.length basically is not 0, we want to return this. Otherwise, we return 0. And so this calculates that value for the very first one in the array, and then it just calls the function again without that value. So the array is basically just getting smaller and smaller, but because we know the length of the array, we know what power to raise each one to. So that's cool. Thanks for the applause, everyone. Cool. Yeah, so there's suggestions for like shift, half. Wait, what was the half about? Cool. I'm proud of me. I'm gonna get a drink of water. Oh, actually, I got some bubbly water today. But I'm gonna go grab some water, and then when I come back, I'm gonna attempt to do what Elisa suggested, where we reverse the array, and then we can just do 2 to the I. Right back. Okay, I'm back, and I have apple-flavored bubbly water. Oh, that's good. Tastes like apples. Skelly's mentioning they posted in the Discord. Let me open that up. Oh, I see. That's what you meant by ParseInt, because ParseInt will take a base, and wow, that's awesome. So you don't have to do the calculation yourself, because yeah, let's look up ParseInt on MDN, and actually let me throw this in my code. So this is from Skelly. And wait, I'm just gonna make this a function, Skelly, just so that my code still works. It can still be a one-liner though. Cool. But let's look up ParseInt, because it's built into JavaScript, and it actually accepts a base as the second parameter. So if you give it a binary number, it'll just do the conversion for you. Cool. So ParseInt parses a string argument and returns an integer of the specified radix. So what they mean by radix is the base. So for instance, you could actually pass a base 16 string and pass in base, like tell it that it's base 16, it'll convert it to decimal. So radix is an integer between 2 and 36 that represents the radix, the base in the mathematical numeral system. So basically what Skelly has done is take the values in the array and smush it into a string that's just like 0001 or 0010. And then when you pass it to ParseInt, it will automatically say, hey, parse this thing, but it's in base 2, and it gives you back a decimal. Beautiful, beautiful. Okay. Cool. I do have the ternary. So I do have the ternary here. I just wanted to show it without the ternary. Cool. All right, let's try to do the reverse thing, because I think this will be actually pretty cool, because it'll simplify the math. Basically, well, let's do the reduce one, because by simplifying the math, it actually makes it a little bit easier to see what's happening in here. So now, before we reduce it, let's reverse it, and now we just do I. Yeah. I like that. So basically, once you've reversed it, here I is 0, and that's 2 to the 0th power. Here I is 1, and that's 2 to the 1st power. So it works. I like this. Reverse it, reduce it, and we're using some value and I. Very cool. Hello, Chris. Hello, Sean. Welcome to the stream. Cool. If I had to choose one, and I'm going to choose one to submit, I'm gonna go with this one. Mainly because it's a single iteration. So if we're talking about complexity, all of these solutions are order in complexity, meaning it takes one iteration of the whole array to calculate the value. This might be a constant time operation. I don't know how ParseInt is implemented, so technically this one might be the fastest. So the only issue with reversing it and then reducing it, it's 2 iterations. You have 1 iteration to reverse it, and then 1 iteration to get the single value. And then this is also 2 iterations. So let's put it in Code Wars and see what they tell us. Sample tests are good. Cool. Ooh, JT is mentioning, if you want performance, store array.length as a variable. That's true, because well, I mean, I'm pretty sure JavaScript stores this as a property, like as a constant value. Like, it doesn't have to do the length calculation, but it could be that it takes slightly less time to look up that the variable in this scope rather than trying to access a property on the array. So let's do this. We'll say like, so right now it took 653 milliseconds. That actually took a little bit longer. Let's see again. I don't know. I do like that though. All right, attempt. Sweet, 50 test pass. Cool. Oh, Alka is mentioning reduce right. I'm curious how that would work. Oh, because that would go from this way, and then you could just use I. Let's look it up. From right to left. Yes, that would make it even simpler. Let's show what that looks like. Cool. I've never actually used reduce right. How new is this? Has it been around since reduce came out? It is in ECMAScript 5.1, so I think this was like 2010 or so. That's awesome. Okay, let's use it. And basically we can take this one that I just did and simplify it. So if we do reduce right, is it capital R? Yeah, reduce right. Now we just raise this to the power of I. Huh? Wrong. Okay, because it's going to be going from... Oh, but what will I be? No, you still have to do the calculation because I technically starts at the length of the array. Yeah. Let's just validate this, but I think that's the issue. So like even though it's going from the right, our I value actually it doesn't start at 0? Probably because that's the index in the array. I got prematurely excited. Yeah, so I still goes in reverse. Womp womp. But if we reversed it, then reduced right? I mean, then we could still use I. Oh well. Did you have something else in mind for that, Alka? So you'd have to... Well, yeah, okay, so I guess so you'd still have to reverse, but what's the benefit if you're reversing to using reduce right over reduce anyways? But let's just show reduce right because I've literally never used that before, so that's cool. Oh no, what did I just do? Open up a TypeScript file. Okay. Hey Amy, welcome to the stream. But yeah, my initial thought though was that because it was reducing from the right, it automatically like it would actually have I at 0 on the right hand side, but I guess apparently not. Oh well. Okay. Final submission. Go. Oh, I see. Alco was just mentioning saw reducing and then reversing. Yeah, and so technically both of these work because it has the right value of I. Oh, cool. Skelly, the one Skelly submitted is like one of the top voted answers. I mean, I think technically, so it's definitely a fun exercise to like talk about what goes into calculating binary. But if I had to do this on the job, I would probably use ParseInt because it's like built into JavaScript. It's probably optimized in some way. Here's some bit shifting. Don't really know what that's doing. I need to do a stream on like bitwise operators and stuff like that because I see them all the time. I don't know how they work. Come on. Cool. All right, let's move on to the next one. That was very fun. Really is asking how do these test cases work? Is it a VS Code thing? So one thing I'll do, you can see me do it in this next one, is I basically just take the tests that they have on Code Wars and just change them to console logs. And then I'm using a tool that runs the code inside of VS Code, which will just log those things out. One thing to mention though is, let me just pull up Quokka because that's the thing I've been using. This team also has a tool called Wallaby.js, which actually is made for testing and will run your tests inside of VS Code. Let's see, do they link to it? Wallaby.js. Integrated continuous testing tool for JavaScript. So it actually runs your tests very similar to how Quokka is doing, but like inside of VS Code. This would be fun to set up, and eventually I could pretty much just take the tests as they are in Code Wars and like use them inside of VS Code. Rogue Soul is asking, was that the first one? Yes, it was. I got started pretty late today. Yeah, and JT's mentioning Me I Am So like Me I Am So is also always the one that suggests or shows solutions that are using like bitwise operators, binary operations. Yeah. Okay, so this one is actually the one that was suggested by California. And I've solved a similar one in the past. Let me see what they linked in the issue. Yes, so exactly the same as a previous one. Squared digits. We're basically every digit in the number gets squared, and then you return a number that is all of those digits squared. Wait, when did I do this? What? Wait, did I not solve it last time? I don't know. I don't even know. So when did I do this? Back in June? June? I don't know. But basically, we have to do the same problem, but we have to do it in 36 characters or less. Okay. Let's try it. I mean, I think I'm definitely going to solve it in more than one line, but once I get it working, I'm going to bring it back down, or attempt to bring it down to as few characters as possible. Cool. They start us off with a nice little lambda function here. I mean, and technically this should be const, but I guess that's a trick that we're going to use. Like by removing the word const, it technically brings the number of characters down. Okay. Let's start up Quokka. Okay, but let's refresh our memories of what has to happen here. So every digit in the number needs to be squared, and that shows up in the resulting number. So here you have 3 squared is 9, 2 squared is 4, 1 squared is 1, 2 squared is 4. So for numbers that end up with just a single digit, I guess seems like it'd be fairly easier, but then things get weird when you start having numbers that when they're squared, they're multiple digits. So 159 becomes 1 because 1 squared is 1. 5 squared is 25, and 9 squared is 81. So you end up with this number there. And hello, Himenshu. Welcome to the stream. Yeah, and JT is mentioning it appears that white spaces count. They do. So yeah, you can see that here they've removed all spaces. Like I said, I'm going to try to solve this with like in a readable fashion, and then if I get it working, I will bring it down to a few characters as possible. I remember last time I solved it like in a very mathy way, but what I'm gonna do is I'm gonna toString it, split it, map it, and then join it. Let's talk through that. So number toString, so that's going to give us something like 1111. We'll then take that number that is a string and split it, which will give us an array which is like 1, 1, 1, 1. And then now we'll take that and map it to be the squared values. Let's use it. I guess we'll use a different example. Let's use this one. So this will be 3, 2, 1, 2. And then we'll map that to square each value. So then we'll end up with 9, 4, 1, 4. And then we'll join it all together. And then we'll like ParseInt or make it a number. So I don't know if this is going to get us there in 36 characters. If it doesn't, we can look at like the mathy way to do this. Yeah, and Alka is mentioning like you don't actually need const let rvar if you're not in strict mode. So technically, like we can just leave that off and it reduces the number of characters. But okay, let's do it. So we'll do x toString. So that's going to give us a string. We'll then split it, which turns it into an array. We'll then map it, and that's going to give us each value in the array, and we want to return that value squared. Are we using node version 8? We are, so we can use the exponentiation operator. That's going to help with character count. So number squared. So number toString, split it, map it, join it, and then make it a number. And you can make it a number by putting a plus sign in front of it. So let's see what we get. We broke it. Okay. So we take the number, we toStringed it. That should give us 1, 1, 1, 1. We split it. Oh, I need to split it on the empty string. And then we're getting nan here, so it could be that you can't raise, you can't raise a string to a power of 2, so we'll make it a number. For now, let's just, I think that's the issue. So like to raise this to a power of 2, we need to do that. And then we join it all together on the empty string. Okay. Was that actually the issue though? Can I do this? Will it coerce it? It does. Okay. Okay. Yeah, and Rogue Soul is asking how many iterations is that? It's multiple. So you have toString, that's most likely one iteration. You have split, that's another iteration. You map it, that's another, and you join it. So 4 iterations. But that seems to do it. Okay. Now, can we see how many characters this is? And okay, so I'm going to turn this into a OneLine function, which means I don't need curly braces. Let's get rid of spaces here. I thought of one way to reduce the number of characters, because like right now, toString is a lot of characters, but you can actually convert something to a string by coercing it to a string. How many characters is this? This is 56. I think this is too many. So one thing I'll do is, first I need to make x a string. So I'm going to say x plus the empty string. I guess I could have gotten rid of spaces too. So now these spaces can go away. Oh. That's 46. I think we've done it. Oh, 36, not 46. Oh no. Okay. Let's see what they say if I submit this. Oh, it passed. Your code is 45 characters long, and wait. Oh, these initial tests are not checking the length. Like if I do an attempt, I think it's gonna fail because it needs to be 36. Yeah. Okay, so we gotta bring it down some more. Okay. Splitting it. It's possible to split it without turning it into a string. Oh wait, it's possible to map it without splitting it. So let's see what that would look like, because I could do a okay, here's what I'm thinking. If I do array.map.call and I call that on this, then I don't need to split it. So that works. So basically what I've done is, instead of splitting this, I can take advantage of the fact that map works on anything that's iterable. And so I'm calling the function on this string and then mapping over it like that. Oh, yes. And so Alicia's providing another good suggestion. So instead of doing like v raised to the power of 2, you could just do v times v, because that's the second power. All right, I still think this is not small enough. 40. So we need to remove how many? So we need to get down to 36 characters. Okay. Is there anything else we could do here? I may go back to my previous solution just to see how I did it with maths and see if that will actually like reduce the number of characters. Okay. Because we're joining it back together. Actually, I don't have any extra spaces. If I remove the plus... Oh, without the plus it works? What? No. No, I have to do the plus because that courses it back to a number. Yeah, so I tried it without the plus. Oh no, so that would I still need this one right here because you can't call map on an integer. It has to be a string because it's iterable. Cat D is mentioning make it an anonymous function. I don't think you can. You have to have a function called, well, it's not technically this is an anonymous function, but it is stored in a variable called SD. So technically this arrow function here is an anonymous function. Okay, I'm gonna leave that there. I'm gonna look at my solution from last time and see if I could, because there's a mathy way of doing this rather than basically like array manipulation and like mapping. Because the tricky thing is you can't just like add these things together. The digits need to maintain their place. So let's actually see how I did it when I could use however many characters I wanted. This one. So iterate over each digit in the number, square the digit, prepend to where we were storing the squared numbers. Interesting. So in this one, I'm using a reduce. This might do it. Okay, let's examine how this is actually doing it. But I think this one might do it because I see some things we can make smaller. And if you're just tuning in, this is probably one of the most esoteric things that I've worked on stream. But like this code kata actually requires that you solve it in under 36 characters. And hello, Flamingo, welcome. And Brooks, welcome. Oh, and Danny is mentioning v less than would be the same thing as squaring. Less than 1. Still, it's more characters though, because it's 4 characters instead of 3. But let's examine what I was doing here. So you take the number, turn it into a string. So you have like string 111, and then you're going to reduce that to take squared numbers, which is a string, and you're just adding on that number. Yeah, so I think that's the thing. Instead of mapping it and joining it, you can do it all in one reduce. So array prototype reduce, instead we could do brackets. That makes it a little bit smaller. instead of num to string, let's just call this x, and this becomes x plus empty string. And then you have like what you're squaring it to, and then you have each individual digit. And then you're going to return s plus d times d. I think that's it. We might have done it. Okay, SD equals x. Is that longer? Do I have extra spaces? It is longer. Dang. Dang. I could use the template string to join. I guess what do you mean by that? Because it's going to be array to string. So let's see how many characters. This is 1, 2, 3, 4, 5, 6, 7, 8, 9 characters. But we're going to replace that with 1, 2, 3, 4, 5. Nan. This will turn it to an array. I don't know if that's what Alka was suggesting. Because maybe what I thought was if you just put an array inside of a template string, it'll automatically join it all together. Alka's saying drop the parentheses and use backticks instead of single quotes. Oh. Oh. Because that treats it that's the hack. Because that treats this like a template function, like a function that can be called. If you're not familiar with template literals, you can create what are called tagged template literals. And so, wow, that removes 2 characters. Cool. Wally was saying your plus was in the wrong place. I don't think so, because what I wanted to do was take that string and turn it into a number. So that's what this plus sign is doing right here. So I'm at 39 characters. Is there a shorter way of calling map on a string, maybe? I'm 38 characters. I gotta remove 2 characters. Okay, I'm not gonna spend much longer on this one because like JT did mention it. I think it was JT. It's just a bad practice, like poor readability. It's a fun challenge. This is in the coding world. This is known as code golf. Whoa. So you search for code golf. There are actual competitions to see like who can write the program with the smallest number of characters or smallest number of bytes. Yeah, and so this is there's a language called GolfScript that purposefully is like very short. It's like hard to read, but this code right here will print 1,000 digits of pi, which is pretty crazy. Okay. Any other suggestions? Like, what can I do here? Let's see. JavaScript string map. A fast and robust string map for JavaScript. think I might call it. Mainly because like this is already hard enough to read as it is. If I look back at my previous solutions, this is basically what I'm doing right now. And excuse me. It turns out that a reduce, there are more characters in a reduce than there are in a simple, well, not simple, in a map and a join. Let's see. Any other suggestions? Help me, please. I could actually, I could give in and click unlock solutions. Should I do it? Oh, and Alicia's asking, can someone remind me what call does? I have no problem explaining what that does because I'm killing time. But people out there in the world, think about it. What else can I do to this? Should I show the solutions? Yeah, and so Danny's mentioning call will invoke a method but allow you to pass your own context. So basically what we're saying is, so array.map is a function, and we're saying call this function, but the first parameter to call is what the context of the function invocation will be. So I'm trying to think of like like the best way to explain this. It really has to do with like the this in JavaScript, where basically any function you can potentially set what the value of this is. So what's happening is we're setting the this value to be the string inside of the map. So when we pass it this function, it's basically indexing into the string rather than indexing into this empty array. So we're like taking the function and calling it on the string rather than calling it on the array. Rogue Soul is saying number at 0 times 2 dot toString plus num at 1. Okay, I'm gonna give myself like one more minute. Maybe I'll have some chat suggestions. Should I just reveal the solutions here, or should I save this for another time and like come back to it? It would be interesting to see what people have done to make this even smaller. I mean, I think the main thing is we have to solve this in a different way, like, because you can't get much smaller with a map and a join. See if there are other ways to join an array in JavaScript. Join an array of numbers into one number. Function.call apply concat. Interesting. Yeah, Akash is mentioning spread. Oh. I do need to get rid of 2 characters. Really, real is just suggesting like S, but I think the issue is your function actually has to have the name SD. Yeah, so like if I try to change this to S, let's see what happens. SD is not defined, so it has to be called SD. Okay, but yeah, so instead of joining it, we can spread it, but the thing is join turns it into a string. Spreading creates an array. Oh, we could, okay, so Alka has a suggestion. I don't want to look at it exactly, but I think I get the idea. So instead of doing a call on map, we can actually just spread this, and then we get rid of call. I think we've done it. I think that does it. Yeah, yes. Okay. So what this does is it takes the string, turns it into an array, and then maps over it. I think that's the winner, Alka. Thank you so much. And I think it's 35 characters. Let's see. Yes, yes. Thank you so much, Alka. And also, Akash was mentioning spread use the spread operator instead of join. So technically, we had to use the spread operator instead of like calling on the map. All right, attempt. Final submission. Whoa. Well, that makes sense. Look at that. These are some really cool solutions. So use template literals to turn it into a string, and then use a regular expression to replace everything in it with that thing squared. Wow. This person did a similar solution to us. This is really clever with that regular expression. Basically, if you're not familiar, regular expression like a replace will actually accept a function as the second parameter instead of just like a string, and everything that matches will get passed into that function and returned and put into the new string. Cool. Cool. Yeah, and Real is asking how, says never got the dots. Danny mentions ... is an iterator for inserting elements from one array into another. Whoa. But basically, and it's called the spread operator because you could think of, okay, I have a string and I want to spread it into the array where each character in the string becomes one index in the array. So you're spreading it. That's the way I like to think about it. But yes, Danny just said, oh my gosh, replace takes a callback. I think I figured this out on one of the Code Katas streams. Pretty much changed my JavaScript life because you can do really interesting things here where you have your regular expression, but then your callback, you could do something extra special where like you take the matched value and like add onto it or pick out the matched values. I don't know, it's pretty cool. Replace takes a callback, and I think match or exec, one of the other regular expression ones, take a callback as well instead of just a string. Cool, that was fun. Thanks to California for suggesting that one. Now we're going to get on to one that was suggested a while ago by Mert Chan. I don't know if you're watching, Mert Chan, but he suggested this a while ago. I've been actively avoiding it because honestly, I see where the issues might arise and I don't know how I'm going to solve it, but we'll see. We'll see where we get. We'll see what happens. So here's the idea. Comparing two numbers written in index form like 2 to the 11th power and 3 to the 7th power is not difficult, as any calculator would confirm that 2 to the 11th is less than 3 to the 7th. However, confirming with very large numbers is more difficult, as both numbers contain over 3 million digits, and JavaScript has floating point numbers. They definitely can't hold on to 3 million digits. Your task is to write a function that takes two arrays in the form of base and exponent, where base and exponent are positive integers, and return the largest of the two pairs of numbers. So for the simple case where it's not a number that's millions of digits, this is a really easy problem, but we have to figure out how we're going to do this for very, very large numbers. All right. Let's give it a try. And Mert Chan, you might not be here, but if you're watching afterwards, thanks for suggesting this. And maybe you can throw a comment down below after I fail miserably. So I'm going to bring all this code locally. Let's grab the tests. Cool. So they have nicely plucked out. So you get two arrays. The first value in the array is the base. The second value is the exponent. Just while I'm seeing this, let's turn this into destructuring because that would be fun. So I could say let base 1 and exponent 1 equal number 1. And then do the same thing with number 2. So if you're not familiar with array destructuring, these 2 lines of code here are the exact same thing as those 4 lines of code. We're basically taking an array and plucking 2 variables out of them here. So that's cool. And really, in the simplest case, we just want to return is base 1 raised to the power of exponent 1. We're doing less than or greater than? Less than base 2 raised to the power of exponent 2. And if we start up Quokka, we need to return the pair, not whether or not it's true or false. So we'll store this in a variable. Oh, actually, if it's less than, then we return number 1, else we return number 2. Opposite. Okay, so this works for all of the simplest cases, but when you have really large numbers, JavaScript craps out. It has no idea what to do. And let's try to visualize that. So let's actually store these in variables. So like we'll say number 1 raised and number 2 raised. And the issue here is we're going to get like some mathematical notation that is like very unprecise, which is why the comparison fails. And let's just log out number 1 raised and number 2 raised. Oh, look at that. It's not even a mathematical calculation. It's just infinity. So when you get these really large numbers, raising them to the power, because JavaScript can't store those numbers, you just get infinity. Cool. Let's catch up. So, oh, Alka is mentioning JavaScript has big int now, so that might work. Let's see. We're in node version 8, so we should be able to use that. How big is big int? So gaming, but not really. I think we have some math theory here. The problem in comparing it is that the bases are different, so we have to get the same base. So turn the big base into the smaller one by representing it in terms of the smaller one. Interesting. And then I might check the Discord to check out your Java code. And JT is mentioning it might require a Lincoln solution. I'm not familiar with that, but we can definitely look it up. Let's just try it with a big int, though. Yeah, Danny is saying node 8 might be too old to support big int. Int 64? TC39 proposal for big int. How does it work? Let's try it. So if it works in here, it's because I'm on node version 10, but we'll see if it works on, what do you call it? Code Wars, the thing that we're working on today. Cannot mix big int and other types. Well, we'll just do this. I think I just broke Quokka. Let me run this with node. Whoa! Those are some really big numbers, and it's returning the right thing. Ah! I think it's failing for these really, really big ones. Let's see. Probably because it's like millions and millions of digits. Let's start up Quokka again. No, I think that's freezing it. I think these numbers are just so big that it freezes it. Ah, and big int, Alka is mentioning, requires 10.4. Okay, so we can't do this. we gotta pull out some maths. Okay. And gaming, but not really, has some maths for us. So to represent it in terms of the smaller base, you have to take big base log small base. Then you multiply the log with the exponent and compare it to the exponent of the other one. I'll have to unpack that. Actually, let me check what you sent in Discord. Whoa! Okay, I'm gonna attempt to figure it out without looking at that. I have to go blow my nose, but I'll be right back. And I think we're gonna be using. Oh, I thought JT was like log the number. No, he's meaning use a log, like a logarithm. All right, I'll be right back. Okay. I'm gonna look up. So before we get too far in like looking into this, I do want to look up the Lincoln solution. Lincoln's math problem. This I don't know if this is it. Or is it? Lincoln log. Lincoln log? Seriously? Or is everyone may not be familiar with Lincoln log, but these are Lincoln logs. But apparently we're going to use Lincoln logs to solve this problem. I had these as a kid. You could like build things with them. Cool. Lincoln log math Lincoln log. Lincoln's log cabin math activity board? What? That's a subtle hint and a bad pun. I don't think that I'm finding it. Lincoln's log. This can't be Lincoln's log cabin. Lincoln's logarithm. Just use log. The thing is, I don't even know what you're telling me to do, but let's try to figure this out. Okay, so I'm gonna write out the identity function that that JT is suggesting. Okay, so the identity you'll want is log of. It's just gonna be a comment. Log of x raised to the k is equal to k times log of x. I see. So basically, what we're doing right now is we're taking x to the k. So base 1 to exponent 1. But if we do this calculation, it'll be a smaller number so that that way we can actually do the comparison. Cool. That was a fun detour though, Lincoln logs. So let's call this number 1 Lincoln log. Actually, so we'll keep here where we were calculating the numbers raised, but now let's calculate the Lincoln logs. Number 1 Lincoln log. So this is going to be, so if it was x to the k, so x is base 1 and exponent 1 is k. So this is going to be exponent 1 times, is it math.log? We're doing log base 10, I presume? Log base 10? Yeah. Yep. Or log base 2. I don't know. Help me. Help me. This will be base 1. Oh, is it like Lycone, not Lincoln? Lincoln. Did I spell it wrong? I spelled it wrong. Lincoln. That's a really weird word. But yes, and so JT and Danny are mentioning doesn't matter what base it is because no matter the base of the log, the equation is still like equal on both sides. Cool. So now we'll do the same thing for this, and we'll do exponent 2 base, and first shout out to JT. Lean cone logs. But now, if we log out number 1 Lincoln log, it's doable. And we log out number 2 Lincoln log. These are small numbers, so we can actually do the comparison. Look at this. No way. No way. No way. Awesome. And this does it. I love it. And so it's like an identity equation. So like we wanted, it was like impossible for us to calculate this because it's millions of digits, but we know this is equal to the same thing, which is a calculable number that can actually be stored in JavaScript, and the comparison is the same. Alka says, shout out to my boy Abraham. Comment from Danny. This is kind of similar to the shortcut when comparing Euclidean lengths. Instead of performing the full square root, you just don't do the square root and compare those magnitudes. Yeah, I like it. Love it. Thanks so much, JT. And also gaming, but not really. Cool. You might not believe this, but I have a minor in math. It's just been so long since I did math stuff. Awesome. I'm just gonna clean this up a bit, like get rid of our comments, and then I'll try to submit it. Cool. Winner. Sample tests. Okay. Attempt. Nice. JT says, pull out your log tables. Aren't there like books of logs? Isn't that a thing? Cool. That was fun. Shout out to Merchan for suggesting this one. Shout out to JT. I could not have done this without JT, and also the suggestion from Gaming But Not Really, to use this equation here to figure out how we can compare but not calculate really large numbers. Final submission. Yeah, I think I'm doing a similar thing. We got a nice little one-liner. Let's write this as a one-liner just to be fun with it. So you have basically what you could do is you can actually destructure in the parameters. So I could do this. Wait. Oh, can't destructure because I need them. What did they do? Oh, they return the whole thing. Okay. So now that we do that, if we want number 1, we return that array. If we want number 2, we return that array. Cool. And then we can kind of write this all on one line. So this is going to be the number 1. And actually, we can do just log instead of log base 10. This goes there. And this goes there. And now you've got a nice one-liner. You could turn this into a nice little arrow function. Cool. Yeah, Wally's mentioning, so if you watch Coding Train, Dan has the book of random numbers where sometimes he'll just read from the book of random numbers, which is awesome. Oh, well, Danny's mentioning they weren't allowed to use calculators in university, so they had literal log table lookups. That's great. Okay, this was fun. Let's move on to the last one of the night. Let's close out these extra tabs for now. Double cola, which at first glance seemed fairly doable. We'll see if they throw anything weird at us. But here's the problem. Can I make this smaller? Maybe not. Let's do this. Okay, so this problem is called double cola. Sheldon, Leonard, Penny, Rajesh, and Howard. Oh, I just realized these are people from the Big Bang Theory. Are in the queue for a double cola drink vending machine. There are no other people in the queue. The first one in the queue, Sheldon, buys a can, drinks it, and doubles. The resulting 2 Sheldons go to the end of the queue, and then the next in the queue buys a can, drinks it, and then also doubles. So you start out with Sheldon, Leonard, Penny, Rajesh, and Howard, but by the time it gets to Rajesh, the array now contains, so Rajesh, Howard, and then there's the 2 Sheldons that went to the back of the line, the 2 Leonards and the 2 Pennies, and then if it continued, 2 Rajeshes would go to the back of the line, 2 Howards would go to the back of the line, and then it starts to like quadruple because the first Sheldon would double, but then the next Sheldon would double again. So basically, you have to simulate these people going through the line and the line getting bigger and bigger and bigger. So write a program that will return the name of the person who will drink the nth cola. So note that in the very beginning, the queue looks like this. So you're given some value n. You basically need to figure out who is the nth person to drink a drink. So like the 51st person would be Penny because it just keeps iterating. And then this one wants you to calculate a very large value. I think this is maybe where we'll run into issues. Like we may not be able to create an array of this length. I don't really know. But let's do it. Okay. Who is next? Okay. Start up Quokka. And let's do a test. Let's do like a larger one, like 52. And the 51st person is actually Penny. Okay, so we have our initial array of people. We have what we're iterating up to, and we just have to do this algorithm. So the first person is going to go to the back of the line twice, then the next person, et cetera, et cetera, et cetera, until we get up to the number that we're getting up to. So we'll need a counter. Current drink or current count. We will iterate up to R. We will take first value in array and push it twice to the back of the array. Increment the drinks or the count and repeat. And then, so take the first value, push it twice back of the array, and then remove the first value. Increment the drink, and then when we get up to R, we want to return like first person in the array. So who's next in line? So the challenge, you're given this array. Sheldon steps up to get a cola, then goes to the back of the line. So let's simulate this for like 10. You want to know like who's going to be the 10th person to drink. So what happens is Sheldon, and let's say our current drink count is 0. Sheldon will take a drink, goes up to 1, and then Sheldon goes to the back of the array and doubles. Now, Leonard will take a drink, goes up to 2, and then there will be 2 Leonards that go to the back of the array. You keep repeating until the count gets to 10, and then whoever's at the front of the array is who is next. So let's code it. This actually seems way too easy. I think I'm gonna have to do something where I have to do some optimization, like especially for this really long number. But let's try it. So a place to store the current drink. This will be a let. Let's just call it count. So count starts off at 0. Now we need to iterate up to R. So let's just do a while loop. So we'll say while count is less than R. Yeah, because when it gets to R, when it's equal to R, we want to return the first value. So we'll iterate up. Take the first value in the array and push it twice to the back of the array. So I believe we can do an unshift to remove it from the front of the array. Let's look it up on Indian. Array unshift. I guess it's just shift, array.shift. Yeah, so shift removes the first element from an array and returns that removed element. So we'll say like current person is the names.shift. So this will take the first person off of the array and we'll move them to the back of the array twice. We'll do names.push current person. Push them twice. Does push accept multiple parameters? Adds one or more elements to the end of the array. So yes, you can actually do comma separated. So we should be able to just push the current person twice to the back of the array. Increment the count. And then return the first person in the array. So we'll return names at 0. That works. But I'm telling you, there's gonna be a gotcha in here because, and I don't know how we're going to account for that. So let's put this into Code Wars and see what happens. Sample tests. I have a feeling we're gonna run out of memory. I don't know. Oh no. Expected Sheldon instead got Leonard. So I think the issue is we need to start at 1 instead of starting at 0. Yes, so count should start at 1. Cool. All right, let's do an attempt. My thought is maybe we're either going to time out or we're going to run out of memory. Yes, execution timed out. Interesting. Gaming but not really has a solution. So while in is greater than 5, in halves, and then you return in minus 1. Did you find that formula somewhere? What does that mean? Yeah, and JT is mentioning the problem primes you for a solution that is not viable for large numbers. So that's the issue, right? When in gets up to the billions, like let's copy these examples. There we go. Let's kill Quokka really quick. And actually, this line right there, I think that one would cause like some sort of infinite loop. There we go. So it works for small numbers, but when we get really large numbers, it's basically just going to run forever. JT is saying, by describing it as a line, you're tempted to use a queue. Yeah, and that's essentially, it's kind of like what we're using the array for, because shift would be like a dequeue, so you're removed from the front of the array, and then push is like an onqueue, where you're putting them at the back of the array. But Gaming But Not Really mentions it's best to think about it in rows. So each iteration of the length will create a new row of twice the length, where everyone occurs twice. Okay. How are we going to do this? Yeah, and the way they talk about it is they talk about it like a queue and a dequeue. Yeah, and Danny is saying, I guess each iteration you go through, you move half as fast because there are twice as many people. So in order to optimize this, hello, Meyer, welcome. There might be a way to think about it. So, and I think the equation that Gaming But Not Really gave us, I guess maybe could you explain that a little bit more? Gaming But Not Really. So I'll type out what Gaming But Not Really has. So while n is greater than 5, in minus equals 2, return in minus 1. So we are having in. Oh, this is taking this really large number and putting it into the space of only 5 things. I see. And that way you actually don't have to calculate the whole thing. You just calculate which one of these 5 is going to be the one. Wow. Okay, I'm going to do this, but I'm curious how you came up with that. So like what's the logic in basically how do you take a large number like this and convert it into something that's in a smaller scale? Okay, so Gaming but not really saying my code isn't entirely accurate, but I think I see where you're going with this. Where basically you don't have to calculate the whole thing. You're just taking this larger number and like mapping it into the space of just the 5. Is that the right way to think about it? They're saying, I think you need to subtract n minus 4 first. Cool. And Mayer is asking, is there any way to suggest katas? Absolutely. So if you go to the Coding Garden GitHub, there's a repo called Code Katas. And on there is an issue tracker. And right now we're just using one issue, but you can add a comment in here with links to ones you'd like me to try. Okay, let's try to do something like this. Let's just leave ourselves a comment. This fails for really large numbers. Okay, and we're gonna do something like this. And I guess here by in you're meaning the number that they pass in. So in minus equals 4. So in the case of 1, in I guess we don't. Oh, instead of 4, and I guess we're not returning it. We're subtracting it, and then we're just returning it at n. So 1, 2, 3, 4, 5. So while n is greater than 5. Oh, and then we need to subtract 1 here. Okay. So I mean that works for the base case because like 1 doesn't even go in here, but then we get the first value in the array. Cool. Otherwise, 52 is greater than 5. We half 52, which is and I guess would we want to take like a math.floor or something like that? Yeah, and Danny's mentioning the number 5 here should be names.length. I think we're always given the same array, but yeah, it's good to parameterize it because basically it's the length of the array. So while it's greater than that, we're going to half in, and then here we're saying we subtract 4. Maybe not. So it worked for 52, so that gave us back a penny. But here, let's just log in. Yeah, so I think we're going to do some like math.floor stuff. Nice. This is it. Too cool. There's some really smart people watching Coding Garden. And I appreciate you. Math.floor of n-1. Yep. Yeah, and then so if like we can throw a few more test cases in here. So like the third person, yeah, if we think about how it's gonna wrap around. So like the seventh person should actually be Sheldon, right? Because he goes to the back twice. I think he's the eighth person too. No, then it goes to Leonard. The ninth person should be Leonard. Yeah. Cool. This is amazing. I tell you what, like these last two problems were extremely math heavy. Not extremely, but like more math than I'm used to. And the chat, the people watching, have definitely pulled through. So there are a few errors here. Did I call you? I did not call you nerds. No, I didn't. I said you're wonderful people, wonderful smart people. Danny is saying greater than names. No, this should be Leonard, I think. Names.length -1. Because index starts at 0. Okay. Attempt. No. Let's log out what our index here is going to be. Or do we math.floor? Well, it shouldn't matter, right? We math.floor in, then subtract 1, but that shouldn't matter. Let's log out what our index is. Let's also log out whatever in they're passing into us. So, wait, what? Oh, no, sorry. I want to log in before here. But I think I can see where this is going wrong. So no math.floor in the loop. Oh, Danny is saying Rajesh and Howard are missing. Oh, okay. Yeah, let's debug that. So like yeah, before I just like plug things in. So 1 should be Sheldon, 2 should be Leonard, 3 should be Penny, 4 should be Rajesh, 5 1, 2, 3, 4, 5. Yeah, so it's missing Howard. This needs to be not -1, I think. Yeah. So yeah, and then 6 would be Sheldon, 7 should be Sheldon, 8 should be Leonard, 9 should be Leonard, 10 should be Penny, 11 should be Penny, 12 should be Rajesh, 13 should be Howard, or sorry, Rajesh, 14 should be Howard, 15 should be Howard, but we're getting undefined. And the suggestion from Gaming But Not Really is math.floor of in times a half. In here? Oh, thank you. Okay, I wasn't getting exactly what Rogue Soul was mentioning. This, I'm curious if they might always give us the same length array, but it is important to note that this should be names.length -1. Because it may not always be an array of length 5. Thank you. That should definitely be that. Oh, I see. And Gaming But Not Really is mentioning, like, inside of our loop here, we should actually be flooring the number on every iteration. And then we shouldn't have to floor it out here, right? Hey! Let's see. So, 14, 13, Rajesh. 14, Howard. 15, Howard. Should go back to Sheldon. And then now we should get 3 Sheldons. Sheldon, Sheldon, and then 3 Leonards. Wait, what? Oh, wait. Okay. Okay, there's 1 Sheldon, 2 Sheldon, 3 Sheldon, 4 Sheldon? Yeah. Cool. That's the winner. Yay! Yes. 2 times 2 equals 4. Quick maths. 1 minus 2 minus 4 minus 8. Okay, so it goes 1, 2, 4, 8, 16. It's doubling every time. Yes, I got confused, but there should have been 4 Sheldons and then 4 Leonards, etc. That did it. You all did the work. I just typed in the code, but that was fun. And final submission. Yay! Super interesting. I really like. Thanks. Huge shout out to Gaming, but not really for this one. But yeah, I mean the way to basically figure it out is instead of calculating the whole thing, you figure out and the way I'm thinking about it is you take this large number and map it back down to the smaller space. Yeah. Jan is mentioning the quick maths. 2 times 2 is 4 minus 1. That's 3 quick maths. Cool. Some very interesting stuff going on here. Number of geeks. Hey. Take the logarithm. Complete cycles. Full cycles. Current cycle. Whoa. Okay. Cool. Danny's mentioning, I'm going to ponder that in minus equals 4 part. So, yeah, I mean, so while the number is greater, so it means it's past it, we then, I think it's bringing it back to the beginning and then having it, right? This minus equals. It's bringing it back the length of the array and then having it. I too will ponder on that. Yeah, and in some of those solutions they showed logarithm because it is exponential growth, like it's doubling every time. Cool. I think that's it for me. Mayur has suggested one. Do I have enough time to do it tonight? I have been streaming from for about 2 hours. Let's see this one. See how complex it is. Maybe I'll do it tonight. It's a 4Q. 4Qs are usually pretty hard. I don't think I'm gonna do this one tonight. It'll probably take me an hour. Cool. Gaming but not really says, CJ, I just want to thank you for doing these live streams. They give me a lot of joy and teaches me a lot. Thank you so much, and thanks for watching. I mean, you helped get the solution to like two of them so far. So good on you. Thank you. JT saying there's no Lincoln emoji. There is a top hat emoji though. There you go. All right, I think I'm gonna call it for tonight. I will push up all of the code that I wrote to GitHub so people can check it out. Shout out to California for suggesting the one-liner. Shout out to Alka, who helped us get there. Shout out to Merchan, who suggested the exponential comparison one. Shout out to Gaming But Not Really and JT, who helped me figure that out. And shout out to Gaming But Not Really on this last one, where we did some maths, some quick maths. Danny is mentioning a Euler problem stream next. I've thought about it. So one thing I'll mention, so last night, I did a stream where I kind of just talked to the community and tried to figure out what's the best way to organize ideas around like what kind of streams I should do. So we created this repo called landscaping, and the idea is we're going to do it based on issues. So you can suggest an idea by opening up an issue, and there are various, we have labels to label the different types of suggestions and ideas. So there are like technology agnostic app ideas for things for me to build, constraints that might be applied to some app that I build, some front-end technology, some back-end technology, something associated with deployment, DevOps, codecraft, things like testing or design patterns, workflow and tools, and then where Project Euler might fit in is something like a show type or series. It might be fun to interchange code katas and Project Euler. Definitely. But yeah, see you later, Anders. Have a good night. Alka, have a good night. Hats off to our 16th president. Oh yeah, and Brooks is mentioning, can't wait for tomorrow night. Absolutely. So Brooks, can you clarify? So tomorrow night I won't be streaming here, but I will be streaming live from the Denver Node.js meetup. We're doing the front end showdown. What do they call it? Let's find it. Node.js meetup Denver. The front end showdown number 2. So Brooks is going to be live streaming this. Are you going to live stream this on your Twitch channel or on your YouTube channel? But I'll definitely be sure to post the link in my Discord, and if it's on YouTube, I can actually embed it on my page. But the idea is Kyle is going to be building. All three of us are going to build the same app. Kyle is going to build it with Vue.js. I am going to be doing it with React. I think maybe if there's enough time at the end, I might do it with vanilla. I don't know. And Brooks is going to be using a framework called Mavo, which I've never used or heard of. Yes, it's going to be a fun time, and it's going to be live streamed. But we basically all have the same user stories, and you're going to see each of us build the same app with each respective framework. And you mentioned you're going to be streaming on your channel, so I'll definitely, if you get the event posted up, I'll embed it on my homepage. But if you're not subscribed yet, check out Brooks Builds. We did a pairing stream a while back where we built a P5 brick breaker game. Brooks streams regularly all about, lately I think he's been coding with Rust and other things. Oh, but it's going to be on his Twitch channel. So it'll probably be uploaded here after the stream, but it will be live on Twitch. And I'll throw the, I'll be sure to throw the Twitch URL in like the community tab if anybody else wants to tune in tomorrow. Cool. And that's going to be a fun time. I'm excited about that. I guess if you want to see, like we did it last year, if you search for front end showdown vanilla, was it the showdown? I think we had a different name for it. Front end face off is what we called it last year. I did it last year. I may or may not do this tomorrow. I think I might just do React tomorrow. But I actually built like a small MVC like component framework from scratch during it. So I did it with vanilla. But yeah, if you search front end face off, you can see the videos from last year. Kyle did Ember.js. I think Brooks did Vue last year. Front end face off. Denver? Yeah, so there's Ember. Michael Herman did Angular. Brooks did React, so you can check those out. And then Twitch's... sorry, not Twitch's. Brooks's Twitch is where we will be streaming. Twitch.tv/BrooksZerker. So we'll be live there tomorrow night. Like I said, I'll post the links and such. And hello, Rebel Fighter. You're late. We're ending, but thanks for tuning in. Oh, and Spectral Piano is asking, what am I using for the inline console output? It's a plugin called Quokka.js. Quokka. You can check out their website. It's Quokka. It's really cool. I actually found out about it from OneLine Function. He did a video on I think like the pro version and showed like all the features and stuff built into it. It's really sweet. Definitely worth it. Julian, hello. You're a little late. We are ending. I keep talking, but the stream's basically over. Awesome. Thanks everyone for tuning in. This was super fun. Thanks for all the help. We'll do it again next week on Wednesday. And wherever you are in the world, have a wonderful morning, afternoon, evening, or night. We'll see you next time, hopefully tomorrow night. Here's this.